In this video, we're going to set up RStudio to compile LaTeX documents containing R code and mathematical typesetting. Now, there are several options for typesetting and report development in R, including R Markdown, Sweave, and Quarto. The reason we're going to use Sweave is that it is the closest experience to writing a LaTeX document. So it really gives you kind of the most control over a LaTeX document. There are some drawbacks in some of the other options. You can create web pages or Word documents, but you do lose a little bit of control for those added benefits. The nice thing is that there really isn't a huge difference between Sweave and Markdown. So if you wanted to switch from Sweave to another one, some of the syntax is a little bit different, but a lot of it remains at least the same flavor, if that makes sense. The syntax changed a little bit, but even the new syntax is the same order, if that makes sense. So the first thing that we have to do is install a LaTeX distribution. So what I'm going to do is I'm going to clear out the console. You'll see there's a little broom here. You can click on Clear Console, and that will clear it. Let's say if I put 5+4 here. You can also use Control-L, and that might be Command-L on a Mac. And what I'm going to do is I'm going to use Install Packages, TinyTech. And install packages works like going to the App Store to download an app for your phone. This downloads all the files that I need. And when I run library TinyTech, that loads it so that I can use the functionality of that package. So the first step, I only have to run once. I've downloaded all the files. And now, anytime I want to use it, in any R session that I want to use it, I can load the library, and then I have access to those functions. So the first thing I want to do with the TinyTech function is install TinyTech. Okay, we'll hit enter here, and this will install a small version of the LaTeX distribution that will allow for the mathematical typesetting that we want to do. Now that TinyTech has finished installing, we can install the second item we need. So install.packages. Again, this is like going out to the App Store. We want to install the knit-r package. All right. And knit is an updated engine for compiling the document. And so what we're going to do is we're going to switch from the default Sweave to the newer knit. And so to do that, we're going to go to Tools. We're going to go to Global Options. We're going to click Sweave. These are the files that we want to work with. I'm going to use let's start at the top. Instead of using Sweave, I'm going to use knit, the updated engine we just installed. For LaTeX compilation, I want to use TinyTech, which we just installed. I'm going to enable shell escape commands. There have been times where sometimes that makes a difference between compiling and not compiling. And I'm going to also do insert numbered sections and subsections as a default. It's just easier to reference sections when they're numbered. And last but not least, I'm going to set the preview PDF to my system viewer. RStudio comes with one. I happen to like the one that my system uses, Microsoft Edge. I have a tablet that I can write on things, so I'm just going to keep it with the system viewer. And this is going to be the setup for my compilation of Sweave documents. So I'm going to hit OK. And one thing I'm going to do is I'm going to restart R. And the reason I'm going to restart R is whenever you install TinyTech, the author recommends restarting R, so you kind of start with a fresh setting. So let's close out of R and restart it. So now we've restarted R. I'm going to go back to our plus sign to open a new file. And I'm going to choose a Sweave file, which is right here at the bottom. And you'll see that it opens up a new document of type article. And I'm just going to write hello world here so we can see that it works. Let's hit the compile button. Okay. So the first thing it tells me is I have to save it. So I'm going to save this as my first Sweave file. Save it. One important thing is you can't use spaces in the file name, otherwise R will get mad. So you notice I sort of just typed it all in one line and .rnw. So now what we've done is we've created a new PDF that says hello world. One of the nice things RStudio has added is this format button. So this format allows me to add sections, subsections, subsections, bold text, italics, typewriter, quote styled text, a bulleted list, a numbered list, verbatim, block quote, etc. So the idea is that eventually you'll just be able to remember that it's dash section, and this is section 1. And let's say it's actually it'll number it for me, so I don't have to do that. So we can do word processing here, and we can look at bold text here. We can see what it's like to do italics. One of the things I'm going to do in parentheses here is you can use text IT, so text italics. Notice this is text boldface BF. Text IT works the same. Okay. We can use their typewriter. Okay. And let's go ahead and compile this. Right? And so you can see the bold text comes out bold. Both of the italics come out italics. And the typewriter comes out looking like a fixed width letter typewriter type font. Bold text is helpful for defining key terms. Italics or emphasis are helpful when you're trying to make a more subtle point. And typewriter is helpful when you're referencing code. So I like to use the typewriter font if I'm referencing a function, just so it sticks out as something different that kind of looks like our code if we're looking in the source document here. We can also do lists. So maybe I can add a subsection here. You can use this button to do it, right? Or you probably could have guessed it was / subsection. So this would be text editing. And maybe we add a new subsection. And we can call this lists. And I can do a bulleted list here. This is item 1, item 2. And then we can use ... And we can also add an enumerated list. Okay, this would be item 1, item 2, ... Okay, so we hit compile here, and it works. You can see we have our bulleted list, our numbered list. Okay, so it just shows we could do a lot of the same things we would do in a Word file or a Google Doc file. The markup is a little bit more code-like. But the main tasks are roughly the same, and RStudio helps us with this drop-down menu for things. Okay? And one of the things that we're going to want to do is add our code. Okay, so I'll create a new section called our code. Notice I typed it out, but you could just do format section if you wanted to. And so one of the things that we can do is we can add, so 4 plus 5. Okay? And one of the things I like to do is make sure there are pluses in between, spaces in between the plus sign, so it's easier to read. And we can compile this. And we see that we get 4 plus 5 is 9. And so the nice thing here is this allows us to create a LaTeX document just like we would if we were typing up a mathematical document. But we can insert our code and output in a rather beautiful way. So other things that we can do with our code is we could do the same sort of thing that we were doing before, where I have something like x is equal to 5. And then I can do x times 5, and that'll give me 25. So I could keep doing this. Okay. And I could print the output. So let's say I wanted to save this instead as a result. I can say the result of multiplying 5 by 5 is, let's see, S expression result, period. And if I run this, it's going to take the value of result and print that here. So S expression says print the value of the object I've placed in here. And so you can see the result is not printed because I've saved it to an object, but it is printed here. And one of the comments you might make, well, it's always 25 because you hard-coded it to be 5 times 5. So let's change it to make it a little bit more obvious why this is helpful. So let's let x be a random number that we sample from the numbers from 1 to 100 of size 1. So the idea is if I run this a bunch of times, you'll see I get 86, 58, 79. It's different every single time I run it. Okay? And then I want to multiply that random number by 5. Well, now I can say the result of multiplying S expression x by 5 is result. Okay? So now I'm using randomization, and I couldn't write this out ahead of time. Right? And if I did, I'd have the wrong answer. Right? Here I have 62. If I were to run this code again, I'll get a different number. Right? Here I get 300. 60 times 5 is 300. If I run it again, I'll get something new. 66 by 5 is 330. So you can see there's this sort of, I'm letting x be a random number from 1 to 100, multiplying it by 5. And even though it's random, I could still write up the result using this S expression technique. Now, one thing that we'll want to do is we'll want our R code to be reproducible. We want to be able to send this file to somebody else, have them run it, and get the same answer. So something we can do is set the seed. I like to use 7272. If we use the question mark to ask for help, we can see the set seed function affects the random number generation. And so in a sense, what's happening is we're saying use this starting point to do the random number generation. And what will happen is if I do that, and let me go ahead and put x here, and I run it a bunch of times, see, I'm always going to get 28 because I'm setting the random seed every time. If I don't set the seed, I'm going to get a different number every time. Okay. For the sake of reproducible reports, setting a seed is really important. So let's compile that one last time. We should get 28 times 5 is 140. And the nice thing is if I were to send this document to you, you should get the same result.